Welcome to this talk on cheap tricks, the nominalist's real problem with physical magnitudes. As you know, Quinian indispensability arguments challenge the nominalists to formalize their best scientific theory without quantifying over mathematical objects. And nominalizing theories involving physical magnitudes has seemed particularly difficult. Call this the physical magnitudes problem. In this talk, I'll argue that a nominalist who accepts certain modal notions independently motivated by the literature on potentialist set theory can answer this Quinian challenge by combining broadly familiar modal if-thenism with two cheap tricks. So let's first set up what I'll say it takes for a claimed nominalistic paraphrase of a scientific theory to be adequate. We presumably don't just want to require that the nominalistic theory implies, say, all of the same consequences for macroscopic objects or sense data. Rather, we want it to, in some sense, imply the same constraints on non-mathematical reality as the Platonist thinks their version of the theory implies. So I'll discuss how to create nominalistic paraphrases which are good in the following sense. They're true at exactly the same worlds at which the original Platonist theory is true. So the Platonist will accept it's metaphysically necessary that T if and only if P of T, where P of T is our nominalistic paraphrase, and they're about as intuitively unifying and explanatory as the original. So, for example, we don't get to paraphrase a finite Platonist scientific theory with an infinite nominalistic theory given by schemas. Now let's turn to the basic paraphrase strategy that I'll be supplementing with cheap tricks. Obviously, to fit this talk into 10 minutes, I've had to yank out a pile of technical details, so check out the very short paper linked below for that. Very crudely, the modal if-thenist idea is that typical mathematicians and scientists' utterances of phi really mean something like necessarily if there are, in addition to all of the physical, nominalistically acceptable objects, extra objects playing the role of mathematical objects, i.e. satisfying certain axioms the Platonist believes the mathematical objects satisfy, then phi. So note that, but we have to cash out the relevant modal notion in some way. Note that if we just cared about translating Platonist pure mathematical statements, like there are infinitely many twin primes, then we could say something like the following. It's logically necessary that if second-order piano arithmetic is true, then there are infinitely many twin primes. Where note that since second-order piano arithmetic uniquely describes the natural number structure, every number theoretic sentence or its negation is entailed by PA2. But to handle applied mathematical statements, like there are a prime number of cats, we need to think about this modal notion a bit more, do something else. Because I can't just paraphrase this as saying it's logically necessary that if PA2, then there are a prime number of cats, right? It's never going to be logically necessary that that's true. And that's not what there are a prime number of cats intuitively means. Instead, we want to say something like it's logically necessary given how cathood applies, structurally speaking, that if PA2, then there are a prime number of cats. So we might write something like this, using the conditional logical possibility operator and the corresponding box. It's logically necessary, given how cathood applies, that if second-order piano arithmetic, then there are a prime number of cats. And some other little quick detail about how to think about this conditional logical possibility operator. You can't say much more about it here, but note that we can use this operator to replace second-order predicate and function quantification in, for example, describing the mathematical structures the Platonist believes in, and that the literature on potentialist set theory and the Borelli-Forti paradox suggests we want to have some such notion. So if you don't like my conditional logical possibility operator, but you know about Linnebaugh and Studd's interpretational possibility operator and like their use of plural quantification, it will be very easy to translate the story I'm going to give into that language. So I won't argue for my why a certain way of formalizing And conceptualizing potentialist set theory is the best here. Whichever way you cash it out, modal if-thenism lets us paraphrase theories whenever we can write down a sentence D, which I call a definable supervenience condition, specifying how all of the relevant Platonist stuff is supposed to supervene on nominalist stuff. That is, on the way that physical objects or non-mathematical objects are related by some nominalistic relations whose extensions the Platonist and the nominalist agree on, like cat and is adjacent to. In particular, we can write such a definable supervenience condition for this short hierarchy of sets, which I'm calling VU omega plus omega, which has exactly the physical objects as elements, and then goes up to a height which is omega plus omega, 2 copies of the natural numbers back to back, which by general estimates is more than sufficient to include all of the sets needed for applied mathematics. In this way, we can nominalize theories which only talk about that nominalistic objects plus this short hierarchy of sets with element structures, in the sense that they have their quantifiers restricted to those objects, and only use the Platonist relations set and element. Okay, now let's turn to the physical magnitudes problem. It might seem like we know how to nominalize science then, right? Because we have a description of all the kinds of mathematical objects that the Platonists might need for their science, and we can paraphrase talk of them. But that's not true. There's still a giant problem for this reason. Platonist theories don't just use set and element, the notions we know how to deal with in our paraphrase strategy. They can also use other language, in particular, to talk about physical magnitudes. They might use this length relation, the length in meters relation, that pairs each spatial path with the real number. And it's not clear that we can modify our description to pin down how this length in meters relation applies in terms of nominalistic stuff in the way that we did pin down how set and element are supposed to apply in terms of nominalistic stuff. Indeed, there's like a long-standing worry that facts about how these physical magnitude relations might not supervene on facts about how any finite list of nominalistic relations apply at all. So we don't have supervenience. It's not surprising that we don't have definable supervenience. Now, measurement theoretic uniqueness theorems have been noted to help somewhat in the case of length, because it turns out that if space has certain features, that I'll define as saying the claim that length is richly instantiated below, then there's only one possible length in meters function, set length in meters function, which assigns length 1 to a suitable meter unit object and respects this pair of nominalistic relations. Path P1 is the same length or shorter than path P2, and the combined lengths of paths P1 and P2 together are equal to the length of path P3. So here we have the definition of length being richly instantiated. All that matters, or a summary of it, see the slides, see the linked paper for more. All that matters for our purposes is that A, this is plausibly true, that length is actually richly instantiated, and B, if you just work through the definitions, it'll be clear that we can formalize this Platonist theory using only our these nominalistic relations and the kosher notions of set and element, which we've already talked about. So, this claim that length is richly instantiated is something that we can straightforwardly paraphrase. All right. Now, the measurement theoretic uniqueness theorems tell us that if length is richly instantiated, then there's only one possible way to assign lengths to paths, as said, that satisfies this obviously necessary condition on being a length in meters function. So, in that case, we have basically a definite description of a set that can play the same role of as the Platonist length in meters relation, the original Platonist. So we can transform our original Platonist theory that uses L to one that only uses set and element as vocab, because we have that definite description, and then we can apply our basic modal if then is paraphrase strategy. So If at all possible worlds, we knew length was richly instantiated, we know that we would have the same truth value for your original Platonist theory phi, the version of it where we replace talk of the length relation with talk of the talk of the unique set that satisfies that definite description, which has the same truth value as this nominalist statement, the modal if then is paraphrase of this phi prime. So one might hope that this is enough and that we can handle talk of other physical magnitudes in the same way. But that's not so likely. We have a problem for two reasons. First, as I just mentioned, it's not clear that it's metaphysically necessary that length is richly instantiated. And secondly, there are other magnitudes like mass and charge, which definitely don't seem to be richly instantiated. So we're left with the same basic problem that it seems like Platonist theories can appeal to these relations, which we don't know how to write a definable supervenience condition for, and hence don't know how to nominalistically paraphrase. So here's where our cheap tricks come in. For concreteness, to explain these cheap tricks, I'm just going to focus on a case where we have a Platonist theory that involves a mass relation, but it will be obvious how to generalize this proposal I'm going to make to theories that involve more relations, more physical magnitude relations. So to explain the first cheap trick, let's go back to temporarily assuming that length is metaphysically necessarily richly instantiated. Now we've seen that at all such worlds, we have a definite description for the intended set length in meters function, and using only our kosher Platonist vocabulary set and element that we know how to paraphrase, and some nominalistic relations. And now it turns out that we can use this definite description to form a definite description of the intended mass and grams relation by saying that it has to assign mass 1 to a suitable unit object, and, here's the interesting part, assign mass ratios in a way that appropriately relates to the lengths assigned by the length in meters function that we've just mentioned, we can definitely describe. So we consider this nominalistic four-place relation, O is as many times more massive than O2, as P1 is longer than P2, and we say that the true mass and grams function, had better say that the mass ratio assign a mass ratio between objects O1 and O2, which is greater than the length ratio between paths P1 and P2, if and only if it really is true that O1 is as many times more massive than O2 as P1 is longer than P2. And the point, which I summarize in a slide and on the talk, is that it turns out in the paper is that it turns out that when lengths are richly instantiated, there are sort of enough length ratios that are instantiated in the world that merely requiring that assign mass ratios that if relate to them appropriately pins down uniquely what the mass function has to do. So if length is richly instantiated at all possible worlds, we can do basically the same thing that we mentioned above. For length, we can know that we will have a definite description of the intended mass and grams relation at all possible that works at all possible worlds, and uses only Platonist vocabulary. We know how to paraphrase set and element and this nominalistic relation. So we have something that we can plunk into the basic modal if then is paraphrase strategy and get a nominalistic paraphrase for. And note also that even if length isn't necessarily richly instantiated, we have that the Platonist must at least accept that we have a partial paraphrase where the Platonist is going to have to at least accept that this nominalist sentence is true if and only if the original theory is true at all possible worlds where length is richly instantiated. Because at all worlds where length is richly instantiated, we have this definite description, and so we know that T will be true if and only if T prime that talks about the definite description is true. But now what about the claim that length is metaphysically necessarily richly instantiated? It remains to get rid of that. And our second cheap trick is going to exploit Quinean holism to let us drop that assumption. Provided that, as currently appears to be the case, our best scientific theory implies that length is actually richly instantiated. So we already have our partial nominalist paraphrase that gets things right when length is richly instantiated, at those possible worlds. We already have a nominalization of the claim that length is richly instantiated, because remember, we said that was easy to formalize using only the kosher vocabulary of set theory with Earl elements that we knew how to paraphrase away. And what we're going to do is simply conjoin those two claims. And as you can see, the Platonist will have to accept that this gets the right truth value for t, the same truth value for t at all possible worlds. Because at worlds where length is richly instantiated, r is true, and p star of t has the same truth value as t. And at worlds where length isn't richly instantiated, t is always false, because it implies that length is richly instantiated. And p of t is also always false, because this conjunct r says that length is richly instantiated, so it's going to be false. In conclusion, I've argued that the nominalist plausibly can address the sparse magnitude problem sufficiently well to answer the classic Quinean indispensability argument. But some important issues remain for study. These concern what I call a grounding and reference indispensability worry. And so the intended upshot of this paper isn't to argue that, the nominalist wins, or the Quinean indispensability argument isn't getting at something that's really important. It's just to say, well, we can technically solve the Quinean indispensability argument as it arises with regard to this worry about how to handle physical magnitudes by applying these cheap tricks, but certain other problems about reference and grounding remains, and it seems like the sticking point is to explain how we can pick out certain or have certain referential abilities, like what could ground physical magnitude facts, etc., not just to state our best scientific theory, and accepting that fact would have some interesting philosophical consequences. So that was why I thought it was worth giving this little talk about.